Okay, so again, we're looking at now this loan formula, okay? It's really the same as a payout annuity formula, if I remember correctly. Okay. It's not much different, you know, P0, remember, that's the balance in the beginning, okay? So in the previous example, it would have been the $1,000, okay? PMT is the payments we're making. You know how, what do you say? Like if you're making a monthly payment, this is what it would be. An annual payment, this is what it would be. It's how much you're paying regularly to each loan. Remember, we're assuming that we're making regular payments. You know, we could even probably do daily payments if we wanted to. I mean, is that realistic? I don't know, but you know, we could do it. R is the interest rate as a decimal. N is how many times it's compounded in a year. Remember, as I wrote it here anyway, but if it's not stated otherwise, the number of times it's compounded equals the number of times we make a payment. So if we're making monthly payments, it's compounded monthly. If we're making daily payments somehow, even if it's not realistic, if we are somehow in a problem making daily payments, then N would be, then we're compounding daily. And T, you know, is the length of time essentially in years. Okay, that's so much fun. So let's now try this out. And again, this is when you use the formula. This is also when you're making many payments. Again, it's very similar to, you know, what we saw before. So, okay. All right. I mean, I mostly threw this in here because the book does, so I figured it'd be good to be consistent with the book. All right. All right. And again, like I said before, we're making not just one deposit like we saw earlier in chapter, I think it was chapter 4 or 5, when we first saw compound interest. We're doing something a little more realistic. We're doing many deposits or many withdrawals. Or with a loan payment, like, you know, a car payment or something, or a mortgage, you know, you're not going to pay it back all at once. We're doing many, many payments. All right. So here's our example. So here's our first example. So here we're looking at a mortgage, okay? We're looking at a mortgage here. Wait, did I? So here we're looking at a mortgage payment of $140,000, okay? And let's say it turns out the interest rate is 6%, okay? 6%, and the loan is going to last 30 years. Now, do mortgages usually last that long? I don't know, but for the problem, who cares? So it's $140,000, 6%, 30 years. The question is, how much is our payment, our monthly payment, going to be? How much is our mortgage payments? Excuse me. Oh yeah, it is monthly payment. So the initial amount, right? The $140,000, right? That's what P0 is. That's $140,000, okay? We'll look for how much the monthly payments would be. That's this, okay? R is the interest as a decimal, okay? So R is interest as a decimal. Good. Then our N, remember, we're doing monthly payments here, okay? We are doing monthly payments. So because of that, N is 12. And again, N is also how many times it's compounded a year, and T is 30. So all I'm using here is I'm using the formula. That's all I'm doing. But we have to figure out what PMT is. Okay, well, in the next slide, as you'll see, what I actually do is I solve for it, you know, just using some basic arithmetic, basic algebra, excuse me. Okay, as you can see. Right, basically here what I did was, I mean, I didn't show the individual steps, but it should be okay. You know, I multiplied both sides by this 0.06 over 12, that is. Then I divided the top by this, okay, to get this. This is our unknown. So you know, here, maybe this will help. You know, so I multiplied both sides first by the denominator here. That's what I'm trying to show you here, although I might be showing more than necessary, but I guess that's okay. Right, and why would I want to do that? Well, again, that's going to kill off, that cancels this denominator with this. So this is gone. And then the next step would be dividing by this. You know, you want to get the PMT part, that's our unknown. You want that to be all alone, as you can see. And then from here, you would get PMT would be all this. And you could use a calculator if you want. You could. I mean, what might happen though is you might have some round off error. What I did was I used Microsoft Excel, right? The numerator I put in one cell, the denominator I put in another cell. Then I divided, and I end up getting this. Now I end up getting about $839.37. That's per month though, okay? That's per month. Okay. All right, so we get that. That's good. Let's now do the same thing, but let's do this now with that TVM solver, okay? So again, all I'm doing here is I'm using the formula, but now what we're going to do is use the TVM solver. So, actually, why did I just do that? Okay, sorry, I don't have to escape out of it yet. So again, there's different kind of notation with the TVM solver, right? There's our PV, which is really the same as P sub 0. Okay, you remember I did present the notation last time. PV again is present value, okay, which is $140,000, right? That's, you know, the loan we want to pay off now. We're looking for PMT, so that's going to be unknown. I is our interest rate. It's really annoying here because in the formula, your interest rate is a decimal. Here, however, you leave it as a percent. In other words, you don't convert it, you don't move the decimal to the left 2 spaces. We get N times T is 12 times 30. Again, that's just, you know, N is 12, right? How many times it's compounded, and which is the same as the monthly number of payments we're making, which is monthly. Excuse me, how often we're making payments. T is the number of years, 12 times 30, which is 360. Now we want to pay off the entire loan. So because of that, we want FV to be 0. We set it to be 0 because again, we're going to pay off the entire loan. So it's almost like what we want owed is nothing. What we want left that's owed is nothing. You know, this is how much we owe now. This is how much we owe in the future. This is how much, again, we owe now, PV. This is how much we owe in the future. Okay? And these two are always equal in that TVM solver. And since we're making monthly payments, they're both going to be 12. Okay? Okay. Okay, so let's go to that TVM solver. Let me just show you that we're able to get this. Okay, so I have to share the other thing. All right, let me just stop sharing this. Here it comes. There we go. Okay, just give it a second. Yep, there it is. See? So this is our TVM solver, okay? So again, capital N we said, right? That's little n times t, which for us is 12 times 30, okay? Our I, remember, that's 6%, right? That's our interest rate, but we leave it as a percent. You know, you don't move the decimal. PV is how much the loan is now. Okay, that's how much the loan is now. So for us, that's $140,000. That's $140,000. Okay. Oh, geez. There we go. PMT is what we're looking for, remember? So because of that, we're just going to leave that alone. Okay. FV, we want that to be 0, so we leave that alone as well. Remember, FV is how much the loan, how much we'll owe in the future. These two are always equal. Okay. So they're both going to 12. How often how often it's compounded. So those are all our data. All our data. So we want to solve for PMT. So we click that. Now you might be thinking, wait a minute, that's negative. That doesn't make sense. Well, it actually does, because the way the TVM solver is set up, negative means money goes out from you. You're making a payment, basically. That's what negative means. So if this was plus, right, PMT was plus, that means we would be getting the money. So PMT, so our payment is the same. Basically, essentially, what you're going to do is disregard the negative, so to say. But anyway, we still get the same payment, which is $839.37. Okay, let me just, okay, let me stop sharing this. Okay, so that's what our screen was. Again, that's that GeoGebra thing. Okay, let me get back to the wonderful slides. All right, that's cool, that's cool. Let me stop the recording, actually.